Hey guys, welcome to Parametric Equations. What? Yes, now this is something completely different and completely like, oh, what do we need this for? And it's going to feel very, very awkward. So let's get started. We're going to go through two examples. I'm going to go over these in a very great and gory detail so that you can feel better, hopefully, to do these on your own after we get done. So here we go. Okay, hey, today you guys are going to be worried about graphing a set of parametric equations. Tomorrow, the next set of videos, we're going to worry about converting parametric equations into rectangular relations and converting rectangular relations back into parametric equations. And at this point, you're going, just tune me out. Okay, yes, this is going to be interesting. So let's take a look at how this works. So, a parametric equation is where it says here, if f and g are continuous functions of t on the interval I, then the set of ordered pairs f of t, g of t represents a parametric curve with these equations. Basically, here's the deal. In our old world, x was our independent variable, y was our dependent variable, and whenever we were modeling real world stuff, okay, in the past, our real world stuff was always something like this, where time was here and this was either height, or maybe instead of height, maybe we had one here that talked about time and this was distance. And that was very, very difficult. What parametric curve enables us to do is to take time out of our independent one and be able to say we're going to have distance and height on the same graph, and we'll be able to see the curve of things and how they move. So instead of being able to say, hey, look, this baseball went really, really far, I can tell why, because it went far, distance wise, or I can see, hey, the height of this baseball went really, really long. Okay, but here I'll be able to see the whole thing. I'll be able to see how far it went and how high it was to get me there, and see the actual curve of the ball or anything. It's really kind of cool. When I first saw this, it was like, I don't get it, but now I can appreciate it. Okay? So let's take a look at these in action, how they work, and we're going to start off very basic, just like we did with Algebra 1, of how to do this. So this one here says, I want to sketch the curve created by x and y over the interval -3 to 3. So first thing we do, I'm going to show you this one by hand, and the other one I'm going to do by calculator. Okay? So the first one by hand. So what you got to do is you need to make a table. And normally we set up a table. We set up an XY table. But this time, we're not just setting up an XY table, but we have T. T is our independent variable. And if you notice, t is an independent variable for x, and t is an independent variable for y. So I go and put my interval in here. I write them in here. -3, -2, -1, 0, 1, 2, 3. And those are the ones I'm going to worry about and try and find. So what do? For each of these here, this -3, I'm going to plug it into my function x of t. Plug it in here. -3 squared minus 1. Is 9 minus 1 is 8. 4 minus 1 is 3. 1 minus 1 is 0. 0 minus 1 is -1. And then it's going to repeat itself. 0, 3, 8. Finally, we do y. Well, what about y? So again, I take t, take the t's over here, and I put them in for y. So the first one is going to be, what is it, -3 fourths plus t, -3 fourths plus t, that's 1 1/4. Okay, the next one, okay, it's going to be 1 1/2. Next one, -1, plug that in there. It'll be a 1 3/4. Plug in 0. It's going to be 2. Notice each one of these keeps going up by a quarter. So this will be 2 1/4, 2 1/2, and finally 2 3/4. Yay! So now how do I graph them? I have my table. Then what I worry about is I read it like a regular XY table. And I'm going to be given a graph, and look, my graph has no lines. This is the other part that takes up time. Alright? So first thing I notice is that my x's are only all positive, and my y's, oh, my x does go a little bit negative, and my y's though are all positive between 1 and 2. So I'm going to put my x line down here because I have mostly positive stuff that's going on. There's x. And my y-axis, I need to make a room for a little bit of negative stuff. So I'm going to put it right here. I'm going to put this as my y. Now I need to make sure I have enough room for everything. So I'm supposed to go out to 8. So let's count things up. 1, 2, 3, 4, 5, 6, 7, 8. So this will be good to just do 1 per show. So this is 1. That means that's 2. That's 4. That's 6. That's 8. And then come over here, -2. My y coordinates are all positive. So, but look, they're all bunched together, right? It's all between 1 1/4 and 2. So 1, 2, or 2 3/4. So between like 1 and 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can do it where every third one, 1, 2, 3, to every second one. So that's 1. Every second one, that's 2. That's 3. And that's as high as I need to worry about. Okay. Let's make that a little bit closer. So I'll do it right here. I'll do 1, 2, 3. All right. Now you just graph points. So we're going to go as quickly as we can. So first one is at 8 1/4. 8 1 1/4. So 1 1/4 is here. And I want to label that, that's my starting point. So I'm going to put an S by it. Because in parametrics, where I start matters. Next one's at 3 1 1/2. So 3 1 1/2. 0 1 3/4. -1 2. And then it goes 0 2 1/4. 0 2 1/4. It's 2 1/2, so 2 1/4 is here. 3 2 1/2. 3 2 1/2. And finally 8 2 3/4. Oops. 8 2 1/2 is here. There, 2 3/4 is here. And that's my finish. So the last part is the easy part, right? Draw this in. It's looking like a parabola on its side. And I want to show which way it went from start to finish. So not only went from start to finish, but I put little arrows describing that motion, how it went from one way to the next. And I put little dots where I started, where I stopped. And the reason why they're dots is because the equals part. Okay? And there's my graph. That's my parametric graph, my parametric equation. So you can kind of see this as, hey, if I was going to be describing my distance and my height, or you can even see this as like a little orbit thing, maybe like a boomerang. I shot the boomerang from over here, and instead of coming back to me, it was a couple feet away from me. Okay? It's describing motion. So that's why we have to have the arrows. All right. Next one. It's going to do this on the calculator. All right. So here we go. I'm going to go and get my stuff on my calculator. Let's get the calculator out. And you guys can watch this on the calculator. But if you need to take notes on what I'm pushing. All right. So here's my calculator. All right. Get this out of the way. So let's take a look at that equation. The equation that we have for this one is is the x equals t squared minus 1 and y equals t over 5 plus 2 on the interval -5 to 5 for t. Well, how do I put all that information in there? Well, you can tell your calculator, I want to be in parametrics. So how does that work? Go ahead and you push mode button. When you push mode, here's your function. Right here, this makes it y equals. This one here makes it into parametric mode, and that's what I want. So I use my down arrows, tab down, go to parametric, press enter. All right. Once I do that, I can press y equals, and you'll notice here, hey, look, I have an x and y, and then another x and y, and x and y, look, and they're 2, 3. So there's a pair of equations for each one. Now I type in my equations. So your second step, type in the equations. And notice when it says t squared over 4, I'm pressing the same button you would press for x, and a t magically appears. So t squared divided by 4 minus 1 gets put in there. The next one is y equals t over 5 plus 2. So t divided by 5 plus 2. All right. And you think, okay, great, I can go ahead and put that in there. The only difference is, the only thing is, I haven't told the calculator which t's to use. And where I do that is on the window. So your third step would be press window. And here I have my t min and my t max. And look, it's set for 0 and 2 pi. I don't want 0 and 2 pi. The reason why it chooses this is because usually a lot of times parametric equations go on a circle. And so which is why it chooses 0 to 2 pi. So my minimum that I'm going to choose is -5, because that's where I want to start. And I want to stop it at 5. I just type those things in there. And when I do that, now I can press graph, and I can see where I'm at. See if it's there. And boom, there's my equation. If you saw it quick enough, you would have noticed it started here and came back this way. And there's my entire graph. Now, how can I find my table? Let's go look at my table. So again, you would press the second button, table. And there it is. Now again, you want to get the table from -5 to 5, so I'm going to scroll up for a second. So your table for t, x, and y, you would have -5, 5.25, 1. Okay. For t, x, and y, you have -4, you're going to do all this. So if you need to, pause me, put down this information. I'm going to again scroll down so people can see the rest of this. And this is the last of it. Boom. And then when I go ahead and I actually graph it, there's the equation. And remember, on your graph, you needed to put where did the motion go, where did it start, where did it finish. Okay, so that means that you're going to put here, okay, just for your own. You don't have to put the S and F. I put that there just so I can do this on my own. And here is that right there. Okay, there we go. That's basic graphing, guys. When you guys get in and you start to doing the work, here's the deal. You can use the calculators to go ahead and solve your problems, okay? but I still need to see the graph. I need it to be detailed. I need you to make a table, a graph that makes sense. For instance, when I go back and I show this graph here, okay, when I was at this one here, notice like my scale on this one was 1s because that fit. Maybe your scale on some of these is going to be so big you need to put 4s because there might be some numbers that are in the 30s. You need to set that scale. I need to see a picture that looks nice and clean. Okay, if you need to, look at the answer book. It'll show you what I'm talking about. Because notice on my scale on this one, the y-axis, it didn't make sense for each of these to be 1 each. I chose them to be every 2, make it 1 because it was so skinny. Okay. All right, guys. I'm going to leave you that with on your own. See you guys next time. Bye.